In this video, I'm going to show you how we can investigate the gradients of perpendicular lines using some software called GeoGebra. So pretty soon, I'm going to show you how we can create this model here, and then we can play around with the gradient of AB and its perpendicular here, this red line, and we can see any results, any relationships between them. So I've written this set of investigations for you here with a detailed set of GeoGebra instructions, but because I'm nice, I thought I would also make you a screencast to make it even easier for you. So here we go, we're at geogebra.org and we're clicking the Start GeoGebra. We're going to go for an algebra view today. Okay, come on GeoGebra. My computer's a little bit slow at the moment. So the first thing to do is to get GeoGebra set up. Now I always go to the menu and I always increase the font size to about 20 at least, and I usually go right click, put some grids on there as well. So the first thing to do is to put a couple of points on the screen using the point tool. I'm just going to select some pretty simple points with integer coefficients. So we've got 1, 1, 4, 2, and their coordinates are displayed up here. This is the algebra window, this is the graphics window. Now we're then going to draw a line segment. Now this tool here looks like a line, but it's actually an infinitely long line. We want the segment which has finite length. So we click A, we click B, and we've now got a line segment called A. There it is. 3.16, I wonder if you can work out what that is. That's the length of the line. You see there's 3, there's 1, and if you apply Pythagoras, you'll find that's 3.16. Now the cool thing is we can move this around. Keep your eye up here on the algebra window. See what happens? It automatically updates. Everything is automatically updating as I move the points. So the next thing we're going to do, let's make that a little bit longer. Next thing I'm going to do is find the midpoint of AB. To do that, I use this tool here. And I can either click the 2 points or I can just click the line. And it's automatically created point C at the 5, 1.5. There it is, there's point C. I'm now going to draw a perpendicular, so a line at 90 degrees to the line segment AB using this tool. Now, I could have just used this tool straight away on AB, but I wanted you to see how GeoGebra can also do midpoints. So the tool, the way we use this is by clicking you can see the tool tip down the bottom here. It says select a point and a perpendicular line. So we'll go point C, and we want the line to be perpendicular to AB. There we are. Now I'm just going to change the style. So I right click on the line, object properties, and I'm just going to change the color to red. Why? I like red. It's a nice color. Okay, and I'm going to change the style too, and then I'm going to close down that window there. So now we have a perpendicular, and note how we can still use this move tool here. We can select this tool, and we can't move point C. Why do you think we can't move point C? We can move the label for line segment A, but we can't move, we can move the line with the label for point C as well, but we can't actually move point C because it's defined as the midpoint of AB. We can, however, if we want to move C, we have to move A or B. Okay? Because it's defined as the midpoint of those points. Notice how everything automatically updates. Now, all through this investigation, I would advise you to stick to integer coordinates here. Right, so the next thing, we're trying to find the gradient of these two lines. So we could start calculating using pencil and paper, or we could use this tool here. Look, on this measuring tool, we've got slope, which is another word for gradient. And all we have to do is select the line. There's the gradient of AB, If I click that line, there's the gradient of line segment B. So let's call the line AB segment A, and the line which is perpendicular to that segment B. The gradient of A is 0.2, the gradient of line segment B is -5. So we have to try and spot a pattern between these numbers. Now obviously we can't do that with just two numbers, we have to find some more data. So the first step in this investigation is to collect some results. Now, to make it easier to see my results, I'm going to add another pane, another window to my work. So we go to the menu, we go to View, and we're going to add a spreadsheet. Spreadsheets are designed to collect data. And I'm going to notice how the tools have now changed because we're in a spreadsheet. And if we click back on the algebra window, we get back to the tools for the graphics window. There we are, and we can also zoom in and out using the mouse wheel. Okay, and we can move everything around just like you can in Windows. Now, I'm going to record my results in this spreadsheet. I'm going to put the gradient of line segment A in here, and the gradient of line segment B in here, collect some data, and then we'll see if they can see a pattern. So it's 0.2 and -5, that was it. Now there is ways for the spreadsheet to automatically collect this data, but we'll do it slowly this time round. So now let's change that to that. So now we can see the gradient of line segment A is 1, shown by this value of m here. And the gradient of line segment B is shown by m1. Or you can look over here, guys. Look, there's m, gradient slope of A, and there's m1, the slope of line segment B. So we just pop those numbers in. Now, I'm already seeing one pattern. I don't know about you, but let's just keep on. Let's get a bit more evidence before we stop and start thinking about our results. Okay, so I'm going to go for, in fact, I'm going to put it there. Let's put A as an integer value. I don't know why that moved. So now we've got, there we are. So now gradient of line segment A is -0.5. Gradient of line segment B is 2. So now we're getting some results. Hopefully we're going to start thinking about the relationship here. There's obviously something going on between these. Okay, so what comes next in an investigation? Well, I've given you some hints over here. First of all, we have to try and analyze some simple questions. So if you look at your instructions, there's a set of simple questions. Once we've got the thing set up like this, I've given you some simple questions to start with. There we are. As the gradient of A increases, what happens to the gradient of B? And when segment A has positive gradient, what is the sign of segment B? Now, you don't have to record all your results. You can just move stuff around and see if you can get a feel for stuff just by looking at how the numbers change. So let's make the line segment A very, very steep. So we give it a very, very high gradient. Things are getting a little bit short of space there, so let's just move it around a bit. Notice we use this tool to move the screen around, and we use this tool to move points and things around. So let's make AB very, very steep. Okay, you can see how steep it's getting there. The gradient's getting higher and higher, and you can see the gradient of B is doing something as well. And we could also try making the gradient of A always positive, and then look at the gradient of B, and then make it always negative, and look at the gradient of B. Okay, so you don't have to write down all your results. You can do this to just get a feel for it. Once you've answered those questions, see if you can find an actual relationship in terms of algebra and numbers. Okay, so we can calculate the actual gradient of line segment B from the gradient of A and go back the other way. Okay, if you can't see the pattern, then try writing down some of these gradients. Rather than decimals, try using fractions. That'll make it easier to see the pattern. And also try making incremental changes to the gradient of A. And by that I mean making the gradient of line segment A go from 1 to 2 to 3 to 4 and so on. So being systematic like that is often helpful. Finally, once you think you've got the relationship, then if you think you have it, then you have a conjecture, you have an idea. It may be right, it may be not. You have to test your idea. So you say, using my idea, if the gradient of line segment A is this, some number, then the gradient of line segment B should be this. And then we'll test it to see if you're actually correct. If you are, great, try and explain the rule. If you're not, back to the drawing board, try again. Try to find another conjecture to test. To get the highest grades, you really do have to explain why the rule works. So we have to provide an explanation, also called a justification, to why the rule works. And there's some ideas there. Okay, so start with the simpler cases and try to explain those. Look at the formula for gradient, obviously. That's the relationship. And draw some clearly labeled diagrams. And finally, just look at these triangles here that we're getting on the screen for the gradients. Can you see any relationship between the triangles? Okay, I can certainly see similarities. We're looking at this little red triangle here and this red triangle here. Can you see any similarities between those? Big clue. All right. Good luck to you guys. This is quite a tricky one, but if you do it, I'm sure you'll feel really, really pleased with yourself. Best of luck.